Okay, we'll go ahead and get this kicked off. We got a lot to cover. So my name is Austin Caby. I'm a product manager at HE Williams. And this webinar we're going to be going over is the lighting overview for healthcare facilities. And first and foremost, I just want to say I hope all you guys are staying safe, practicing your social distancing. We're in some interesting times right now, and it's really cool to see the lighting community really come together, embrace this, and just move forward with this kind of technology. All of these webinars we're doing, these video chats and everything. So it's just really cool. And we're talking today about something that is very, very prevalent at the moment. Always prevalent, but even more so in the environment that we're dealing with today. So again, this is a lighting overview for healthcare facilities. We're kind of going to be looking at how to best design lighting for healthcare facilities. So a little housekeeping. Credits earned on completion of this course will be reported to AIA CES for AIA members. Certificates of completion for both AIA members and non-AIA members are available upon request. This course is registered with the AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material or construction or any method or manner of handling, using, distributing, or dealing in any material or product. So through this PowerPoint, we're really going to be focusing kind of on 4 objectives. So the first objective we're going to be after is identifying various types of healthcare facilities and impact of lighting and electrical usage. The second one, identifying who is impacted by lighting in the healthcare facility through its design and functionality. Third, identifying various lighting design considerations, constraints, and specifications for the healthcare industry. 4, identifying alternative design methods, including color temperature, controls options, and various space lighting applications. Just to let you guys know, I believe there is some quiz questions at the end of this, so you'll want to be taking notes of things as we go through, unless you have an iron memory. So we will have some questions at the end of this. So learning objective number 1, identifying various types of healthcare facilities and impact of lighting and electrical usage. So the domain of healthcare facilities, we all know that healthcare campuses are massive and there are multiple areas within these facilities. So modern healthcare lighting application goes beyond just the standard hospital setting. You know, healthcare facility services vary from one another, many providing specific healthcare related solutions, while others provide multiple healthcare options. So you go from a routine doctor's visit to an extended care rehab. A well-planned healthcare facility provides optimal illumination, improves caregivers' effectiveness, provides patients a sense of comfort and safety, also while providing friends and family with a hospitable experience. So looking at lighting spaces within healthcare facilities, you know, all the individuals that are going to be coming in and out of the healthcare facilities are going to be looking for different things within kind of the lighting realm, or need different things within the lighting realm. So from birthing centers to like surgical suites, the lighting must be accommodated the specific health related tasks performed within the space. You know, properly lit rooms, aid stations, corridors, all these are going to provide, you know, obviously the ability to effectively help staff perform their jobs. And just in the end, it's going to result in better care and well-being for the patients. So everybody's going to have, you know, we're going to see a lot of the same lighting throughout hospital areas, but we're also going to see very different criteria for different areas within the hospital. So the impacts of effective lighting design. How can we design lighting in the hospital setting to be most effective? What are we really after in this design? And that is really to improve the comfort of the patients and provide a healing experience through lighting. Lighting obviously is going to impact the welfare of patients, staff, and visitors. Every time you go into the hospital, that's one of the first things you're experiencing is the touch of light, basically. And the healthcare industry is in a state of constant change as new treatment, technologies, and procedures continue to evolve. As the industry changes, so must the way we design the spaces. And this is extremely true in the healthcare industry. I mean, the healthcare industry is always on the cutting edge of technology because the business they deal in is the business of saving lives and helping people overcome ailments. So being on top of our game in the lighting industry is going to make that much more effective. It's going to be much more cohesive. So benefits of LED technology, all of you should be able to rep this off the top of your head and go into deep conversation about each one of these areas. But we know obviously the benefits are low maintenance, it's going to be more energy efficient, and definitely environmentally smart. So LED really is the way to go. And we all know that. We all see that now. Majority of the nation has gone to LED. So this is going to continue to grow and be prevalent. So hospitals are the second largest energy consumers in the commercial marketplace. The second largest energy consumers in the commercial place. That's a huge number. So LEDs aid in reducing energy bills and minimizing carbon footprints. What an opportunity there. So this chart kind of shows a breakdown as far as what we're looking at within the healthcare facility electrical use. So you see the pie chart on the right here. You can see that 42%, so almost half the healthcare facility's electrical use is coming from lighting. That is a massive percentage. On the left, we see that kind of an industry breakdown of where healthcare hospitals sit within a bunch of different industries, being second only to food services. I mean, we're talking huge opportunity to move lights and huge opportunity to really reduce our carbon footprint, because if this is the second largest industry in the nation, then how much more effective can we be if we're looking to make hospitals greener and more efficient? So that was really the first learning objective. And now we're getting into the second one. So the second one we're after is identifying who is impacted by lighting in the healthcare facility through its design and functionality. So who do we impact? Who do we impact as designers, architects, distributors within the hospital setting? Anybody and everybody. Anybody that's going to walk in and out of a hospital door is going to be impacted by the decisions we make within the lighting world that's implemented in these healthcare facilities. So everybody's going to have different needs within this. Your facilities and maintenance staff ensure that lights in the facility are in good working order and able to accommodate the daily needs of staff and patients. So very important. Proper lighting allows medical staff to efficiently and effectively care for their patients. Even more important. And then family members, obviously in this time, it's not always easy. Usually we're dealing with some kind of crisis or ailment that's not ideal. So proper lighting is really going to help cultivate an environment that eases stress and worry. And then proper patient lighting helps create a comfortable environment that promotes a more expedient healing recovery process. So, if we can design lighting efficiently in all these different spaces for all these people, it's really a win-win for everybody. Everybody's going to be benefiting from this, and we're going to be literally helping people heal faster because we have designed lights and criteria to specify the needs of healing and well-being. So within your healthcare facilities, the occupants that are in there are going to still need different types of lighting. So looking at your staff, obviously your hospital staff includes, maintenance administration, gift shop clerks, cafeteria personnel, technicians, nurses, doctors, surgeon, et cetera, et cetera. So what they're after is they want good visibility that eliminates hospital eye strain and fatigue while providing an environment that supports a productive mood and alertness needed to meet the rigorous demands of the hospital environment. And rigorous demands in a hospital environment is really no joke. I mean, you're talking nurses, doctors working 12-hour shifts under sometimes intense pressure, intense concentration. So to be able to assist, our hospital staff by designing light that eases their eye strain, or that gives them a little peace and comfort and makes them more effective in their job is huge. So when we look at patients, patients are going to want a little bit of a different viewpoint. So your patients, you're looking at maybe newborns, geriatric, inpatient, outpatient. It could be routine lab work, ICU, NICU, emergency, and et cetera on that. So they're looking for more proper bedside handheld controls. So that's going to give them the functionality to control their environment by allowing them to make changes with them in their room. So not only does this help provide really an overall comfort for the patient, it allows medical staff the ability to provide care without interrupting the resting patient. So you really kind of have two things here. You're looking from the patient's view, where you're actually giving them an element of control from the bedside. So obviously when patients are in a hospital, they don't have much control. So giving a little bit of that element back to them, I think is huge, and just allows them a little bit more comfort in their setting. And at the same time, it's going to benefit your nurses who are coming in. So your nurses or whoever can come in, and they can turn on specific lights that aren't going to really maybe affect the patient that's in the room. And then your guests are going to be looking for something a little different as well. So your guests would be people like, patient friends, anybody and everybody like that. And so really what they're after when they go into these places is, hey, I want a home-like atmosphere to be in. When I come in, I want to feel calm and comfort, try to uplift their spirits with the type of lighting. And we can do that with lighting. So lighting for staff, kind of diving a little more into these verticals. So, lighting for staff, controls is a big thing. It's going to provide staff with the flexibility to change their environment based upon needs or time of day. Nurses stations or reception areas are going to require well-lit work for staff, but need to be an attractive atmosphere for patients and visitors as well. So this is where we kind of see this bleeding of the patients and staff being in the same area, needing a little bit different lighting, but also the same. So appropriate light levels promote increased alertness and visual acuity, thereby decreasing human error when treating patients. And I think that's something we all want when we go to a hospital. A priority for all hospitals and personnel. With the lighting needs of both day and night shifts in mind, healthcare fixtures provide exact lighting when and where it matters. So that's a big deal. I mean, again, we're talking with these nurses working night shift, 12-hour night shifts, they're going to be dealing with some different biological, maybe issues because they're working through the night shift, and we're not necessarily designed to work through the night. We'll kind of get into our circadian rhythm and how that really plays a part, but having the correct light throughout the entirety of the day, hospitals 24/7, nonstop, all day long. So if we can add these controls and these options and this tunability to be able to affect that and change the levels for the different staff that's working or coming in, can be huge, and we can cut down on mistakes or any kind of issues. So your medical practitioner, I mean, these are going to be your doctors and nurses caring for the patients as well. So proper patient lighting reduces shadowing, which can impede a doctor's sight during a thorough examination. Obviously, we want the doctor to see as well as he possibly can whenever he's doing whatever he's doing. And so being able to design the light to where it doesn't create those shadows is hugely important. And then you can add elements like sanitary shielding, just allows for easy cleanup while reducing the spread of infectious germs and viruses. HIAs, hospital infections, and deaths are huge. I mean, it's a big number, surprisingly big number in the US. And anything we can add to cut down on this, whether it be antimicrobial or sanitary shielding on fixtures, is something that we're going to want to think through and add to what we can. So patient night lights allow for mobility during the night and easy access to patient without having to turn on the overhead lighting during the nighttime hours. So again, it's that kind of multi-compartment fixture where you can turn on certain lights within a fixture that aren't going to intrude too much on the patient's staff or on the patient or on the staff. So we get into these specialized rooms within a hospital setting. So you think of your surgical suite lighting applications. So these specialized areas require fixtures that direct light asymmetrically and contain a green source for ease of eye strain during long operations. It also distinguishes between different tissues because of varying degrees of red, such as blood. So surgical trophers nowadays, you will see actually carry a green circuit on them, much like this picture you're seeing here. And so you have white and green circuits basically that you can switch separately. Now, we found through studying that there's a huge benefit to this green light. One of them being that it does help create contrast in blood. So you're getting different reds when you're in surgery, tissues, veins, whatnot. It also, the biggest thing I think with green would be that it reduces all eye strain. So think about a surgeon nowadays. You know, he might be doing videoscopic surgery for 3-5 hours. So he's doing his surgery mainly through a video monitor. And he's looking intensely at this screen to do his work. Now that would create some major eye strain. I think all of us, work in front of a computer a lot of the day. And at the end of the day, when we're on and off, even we have eye strain. So think of the eye strain on a surgeon in that manner. So what this green circuit does is they would really turn off all the white light in the room and they would run the green circuit only. So then you're cutting out all eye strain for the surgeon. You're adding contrast of the red bloods to be able to see a little better. And then another big win for green is that it cuts down on glare for screens. So you're not getting any of this glary imaging in your screen so you can see clearly without interruption. So this picture kind of just shows you a little bit more of what these types of rooms might look like. And you see all this task equipment just everywhere and anywhere. So the positioning of fixtures eliminates shadows, and it's really going to focus light directly towards the patient. Typical applications are generally a rectangular pattern surrounding the operating table. Surgical fixtures direct light symmetrically or asymmetrically, depending on the type of surgical suite. So again, just trying to get that light at certain angles, so we're missing a lot of this task equipment that's in the room. And then your green lighting capabilities offered for many surgical fixtures. So we just talked about the benefits of adding green into your surgical fixtures. So looking at the patient, what's going to help the patient the most in these settings? So research suggests that a windowed room with a daylight view can reduce stress, pain, and recovery time. So effective onset for mood treatment is 2 weeks for light versus 4 to 6 weeks for antidepressants. So think about that, the effect of natural light on the human body, how much more it helps an individual heal. And now with LEDs, we can recreate that with lights. So daylight access in patient room reduces amount of self-administered pain medications as sunlight increases serotonin levels. So huge win there. If we can help cut down on pain medications that being administered. We have a huge problem in the U.S. With pain medication dependency. And so what if there's a better way that we can do this? And there really is. We can do it through lighting and sunlight. LED technologies do provide the ability to mimic natural circadian rhythms by altering color and luminosity. So patient areas, this is going to be from your birthing centers to your long-term care facilities. The lighting needs to accommodate a variety of requirements. So again, hitting that multi-function, multi-compartment luminaires just provide the flexibility, suit the needs of both patients. So again, you're giving that almost dual purpose application that's going to fit the needs of the patient as well as the needs of the staff. So various, lighting compartments and bedside lighting controls provide personalized control. So again, giving back controls to the patient, at the same time allowing those controls to the staff. Procedure rooms. So proper procedure lighting reduces shadowing, which can impede a doctor's sight during a scanning or testing. Sanitary shielding allows for easy cleanup while reducing the spread of infectious germs and viruses. And then glare free is going to create a calming environment during patients' procedures. So, any scans and stuff, obviously you want the doctor to see those scans with 100% clarity. No kind of, don't leave anything up to chance when they're looking at, whatever it is, x-rays or whatnot. So lighting in these rooms are extremely important, that we're going after the standards and making sure that we're properly lighting it as best as possible. So this is kind of a continuation. You have these specialty rooms. So just like the one before, there are going to be certain rooms, maybe labs or pharmacies within the hospital settings, that require maybe clean room. So your clean room rated fixtures are going to carry a lot of certifications. So they're certified NSF, which is the National Sanitation Federation. They're going to carry like IP65, ingress protection, ISO 5, which is International Standards Organization. And these requirements just ensure that contaminated particles do not enter the room from the plenum space. So you think about, a lab, for example, and all the elements that they're dealing with, very susceptible to outside elements or particles. So it is extremely important that we have the right rated fixtures to service these rooms, because you're talking sometimes millions of dollars tied up in this research. I mean, life could be life or death, the next cure for cancer, and having the proper rated fixture in there is going to make them just more efficient at their job and not waste any time. So now we get into like, say a NICU, so premature babies we're looking at. Obviously, infant NICU cost is astronomical, and it's not looking, at life and a monetary value, but it does. I mean, it just costs a lot of money. So how can we look at, as lighting designers, as people who are implementing light, how can we look at this and help this solution? How can we provide a solution for this? So getting into kind of babies and their kind of fetal biological clock. So, and how lighting affects that. So a fetal biological clock is an endogenous clock capable of generating circadian rhythms and responding to maternal and training signals. By at least the third trimester of pregnancy, fetal diurnal rhythms are entrainable by maternal day-night rhythms. Maternal illness during pregnancy and premature birth are obvious clinical factors that may adversely affect circadian rhythm development. Premature birth of the fetus has the most dramatic impact on maternal-fetal interactions. The effect on biorhythms appear to be temporary, and it is greatest on the most immature infants. So again, talking about the circadian rhythm is started at such an early age. The results to date support the importance of fetal circadian rhythms and the relative lack of these rhythms in premature infants. So it's well known that growth and development in premature born infants are influenced by a multitude of factors. Clearly, I mean, this is a given no-brainer. The neonatal intensive care unit is not a surrogate for the maternal placental unit. Nothing can take the place of the mother's natural womb. So really what I just talked about is based kind of on an article that reviews what is known about circadian development in the human infant, really with an emphasis on unique circumstances of the preterm infant. So really studied on preterm infancy and how their circadian rhythm is affected by being born too early. So the research on that was short and long-term effects of environmental interventions on circadian sleep and neurological development is further discussed in there. So although an earlier onset of circadian development did not result with cycle lighting, in the neonatal nursery, there may be still an important biological effect that has not been studied. So that study took place where they did not have cycle lighting. So we weren't, with that specific, study, weren't able to see if lighting could really affect the development of a baby in the NICU. But there are studies going on right now that are taking place right now to find this out. If we put some kind of tunable light in the NICU over these babies that still need to develop, and we can almost entrain them to the cycle that would have been naturally given to them while they're in the womb, what can that do? Is there a huge difference? And so I really think, I think there will be some benefit from this. I think we will see that providing this natural light cycle would help the babies and train their circadian rhythm more naturally while they're in the NICU, thus allowing them to grow more naturally and heal quicker and leave quicker. So it's going to be really cool to see how these studies turn out. And I think as we gather some of these studies, you'll start to see some standards roll out from the groups as far as how to achieve or how to affect what is most effective in these types of units. So we went from premature babies, and now we're on the other end of the spectrum, older adults. So 46 million Americans are over 65. So right now, 13% of the nation's population, 65 and over. This is estimated by 2040 to be 22%. So by 2040, we're looking at almost a quarter of the population being considered 65 or older. So in that segment, 85 is the fastest growing segment. So a huge number that we're seeing and continually we'll see grow is this older adults kind of population. So over 1/3 have memory issues. And we all know as we get older, our memory doesn't serve us as it once it did. I mean, I have memory issues now and I'm only 29. So, within this group, they're going to be dealing with some different things. So you have memory, and then 23% have depressive symptoms. So that's a relatively large number to have depressive symptoms. And then we start looking at your nursing homes, your assisted living. So assisted living costs can be upwards of almost $4,000 a month, or a nursing home cost could be $7,000 a month. So there is a huge area that lighting, as we as light, reps and people have an opportunity to service here, and really for the benefit of the entire community. So there are studies that are going on and that have just completed where we really get to see how lighting can affect some of these areas. So just take, for example, this depressive symptoms. The Rensselaer Polytech Institute just did a study, and they were trying to see in certain areas of assisted living how we can decrease depression, how can we get some of these people who are stuck in their chairs all day, how can we help regulate their circadian cycles to be more natural. So, what they did is they had a control group, and they were trying to basically blast light into some of these, you can call them elderly patients, areas where they stay. And what they found actually, above overhead lighting itself did not get enough lighting into the patient's eyes to be able to really make a difference. And you think as you get older, you get a little maybe hunched, or you look down, and especially more so for these areas where you're talking that these individuals are going to be sitting all day long. And sometimes at nursing homes, they get wheeled up to one area and they sit all day long. So what the Polytech Institute did was they actually built like a light table. So think of a flat panel that is a table. And so this would allow the light to come up into the direct eyes of the patients. And what they found through this study was an awesome percentage increase in depression was cut down. Their circadian cycles were more naturally entrained. They had various other benefits, and I would, suggest if you have some time to go to their their website and kind of read through that study, because it's quite fascinating what they found out with lighting, that they can achieve with lighting to help some of the elderly population. And more studies like that are going on. And even you talk like your amber night lights are going to reduce falls. When we're older, we're not as flexible, so we easily trip up and fall, and that can lead to other bad things. So just by adding a little, say, a sensor to the bedside or something, so when the individual gets out of the bed, the light in the bathroom kicks on so they can see. So just little things that we can think about, and really a lot of white papers that can back up some of this, this new design that we can implement in these spaces. So loved ones and general public. Obviously, we're looking at hospitals can be high anxiety environments and care facilities. So what we want is more of a warm, pleasant waiting areas to help make visitors feel calm and comfortable. Lighting is an essential element in designing such a space. Tunable color or dim to warm technologies with quite smooth glare-free lighting to create a relaxing ambiance that feels like home. So now in these spaces, we can add these elements, maybe like dim to warm or something, to set a little more calmer mood in these places, or maybe add some tunable color into these spaces. So in all this with the patient, whether it be the staff, doctors, nurses, family members, our facility guys, maintenance guys are going to be ones servicing all these lights that we're walking under. So they're going to be coming from a little bit of a different viewpoint than everybody else. What they're going to be looking for is either flexibility, modularity, fast turnaround time. So they want easy access to the guts of the fixture, toolless entry, and generally only one person coming in to service the fixture. And so what you'll see a lot of times that in patient rooms, the fixtures in there are all room side access. I mean, that is a huge to do in these specific rooms, because you think about if somebody had to get into a plenum space of one of these patient rooms, well, you literally have to shut the patient room down. And every minute, that this room is shut down, that's potentially thousands of dollars wasted, let alone the cleaning crew that would have to come in and do a deep, deep clean because of all the dust particles you could have disturbed in the room. So what they're after is, I want one compartment, come in, flip that door down, there's my driver, switch out my driver, whatever it may be, in and out under 10 minutes. And then these guys' fixtures have sandy shields on them, so they can flip that back up, wipe it down, and then your regular cleaning crew can come in and do what they need to do without any interruption in the schedule of the room. So learning objective number 3. We're going to identify various lighting design considerations, constraints, and specifications for the healthcare industry. So this is kind of guidelines for the patient room, and I'll just kind of go through these because they are kind of standard. So room dimensions are roughly 15 foot by 16 foot by 10 foot in height. So you're going to want large open windows for greater daylight, options for controllable blinds for the patient's comfort, again, giving a little bit of control back to the patient when we can. Lighting functions include dimmable, ambient, reading illumination, and exam functions. Patient's ability to control lighting and interior environment from the bed. Bathroom lighting controlled by vacancy sensor. We all want to see when we get up and walk to the bathroom. Your lighting power density is 0.62 watts a square foot or under. And this obviously does not apply to the exam function, because when the doctor walks in, he's just going to blast you with light. Light levels of patient room meet AIA's handbook. So night lighting allows low-level illumination for nursing staff, observation, and patient safety. Spectral distribution supports circadian and cycle entrainment. So there are a few patient room lighting methods. This one is called the head wall method. So your traditional kind of hospital multifunction lighting is going to produce more of a comfort kind of ambient light, along with a highly functional reading and night light. The direct and indirect components are fully isolated and separately switchable using a pull chain bedside controller or wall switch. So we have another method, that's a ceiling method. So this type of fixture allows for direct uniform illumination above patients in various configurations, including ambient and exam, reading, or nurse. Lighting can be controlled via the patient's pillow switch, side control, or by medical staff near the doorway by the wall switch. And then the last one is the hybrid method, which is just the last two put together essentially. So we see within these areas, some of them are going to require some very stringent certifications on these fixtures. So we would call those kind of mil-spec or Milstead requirements. You know, Milstead really just establishes verification requirements for the control of an electromagnetic interference, characteristics of electronic, electrical, or electromechanical equipment, and subsystems designed or procured for use by activities and agencies of the Department of Defense. Such equipment and subsystems may be used independently or as an integral part of other subsystems or systems. So to summarize that, the fixtures in these rooms are going to need some alphabet soup of ratings, and that's just because, again, the government requires further stipulations. So part of that would be something like an MRI room. So like an MRI room or suite is going to need non-ferrous materials. So what you would see kind of in these rooms is that you would actually, all drivers for the fixtures in these rooms are going to be remote mounted, placed outside the rooms, because you have a giant magnet in the middle of the room. You don't want any kind of metal anywhere around that. So the drivers themselves, you know, the fixtures are going to be wired, and they have to go through a filter through the wall to the drivers. So again, that's just kind of some of your stringent requirements depending on the space or room that you're in a hospital. So learning objective number 4. So we're going to be identifying alternative design methods, including color temperature control options and various space lighting applications. So this is where we're going to start talking about, we've been talking about circadian rhythm, tunability. We're kind of going to look a little bit more into that and how to really affect that. So healthcare lighting criteria, you know, different sources of light have many color temperatures available. We started off with incandescent. It was warm and it just mimicked a candle's flame. And then you get your introduction to fluorescent. This gave us a little more room to work with, where we're looking at a variation of 3,000 to 5,000 K, depending on the phosphorus that was used. And then we get into LED technology, which just blew the roof off everything. So now your ranges are from 2,700 K to 6,000 K, and that's even more so. I mean, there's some ranges out there, they're like 1,650 to 9,000. So LED has really opened this up in a wide breadth of what we can achieve. So, you know, at the same time being tunable and controllable, we can set these, you know, tunabilities to different daylight ranges, allowing for kind of our cleaner, more circadian rhythm entrainment. So circadian systems, I've been saying this word a lot. Some of you might already know what it means. Some of you might not. So we're kind of gonna learn a little bit about what this actually entails. So we are wired to circadian rhythms, all of us are. I mean, right out the womb. We talked about that with premature babies and how early this cycle begins in us. So circadian rhythm is a natural progression of change of color during the day to night that affects chemical reactions within the body. So you have melatonin, and that's going to be released at night. It says, okay, body, it's time to go to sleep. And then your cortisol is going to be released in the day. It says, okay, body, it's time to wake up. So this is the circadian system. This is a little chart, pretty interesting to chart to see how the circadian system regulates different things in our body. So all plants and animals exhibit repeating patterns of behavioral and metabolical changes over an approximately 24-hour cycle. So this term was coined by Franz Hallberg in 1950s at the University of Minnesota, Laboratories of Chronobiology. Circadian rhythms are influenced by both exogenous and endogenous rhythms. Light, dark contrasts, as well as blue light, are the strongest entrainment stimuli for the circadian system. So we can kind of look at this chart down here and see how our circadian rhythm tells our body to do different things. So think about how important this is in a hospital setting that's running 24/7. So what if, again, we kind of go back to that, night shift workers, their body clocks all kind of, jacked up. And so what if we can make lighting mimic that of a natural daylight cycle? Well, then we help and train their circadian rhythm to be more normal. So their body is saying to, wake up when their shift starts instead of go to sleep because it's the middle of the night. And this can be looked at in all different levels, not just hospitals. I mean, think about all of us today where we're at. Most of us are working remotely. Houses are not ideal to work in because a lot of times they're dimly lit or running 3,500, 4,000K light bulbs. And so really what that's telling our body all day long when we're working is, hey, I think you should be getting ready for bed. When really we should be more under this blue light that says, okay, now it's time to work. Now I'm going to be releasing the right chemicals to help us be more efficient. And so there's a lot of study that has gone into this, a lot of white papers that support this. So how much more effective almost as human beings could we be if we're constantly under the right light all day long? That's going to affect our health, our sleepiness, our performance, anything and everything. So this circadian system is extremely important, and I think it's something to definitely keep an eye on as tunability in the lighting world kind of grows and really becomes more of a standard in certain areas. We'll be able to achieve this stuff, and it's just going to make us as individuals working just so much more effective in the areas that we're working at, including hospitals. So blue light asset liability. Recent studies have indicated that blue light can be beneficial with exposure during the appropriate day hours. So consequently, blue light during nocturnal hours can have increased harmful costs. So that kind of goes back to, when doctors told us, hey, don't look at your phone in the middle of the night. And the reason for that is because phones carry a ton of blue light. They did. Nowadays, you'll see phones with a lot of filters. But a couple of years ago that we didn't really know that as we were getting into this kind of new realm of understanding how light affects the circadian rhythm. But at night, all this blue screen light would tell our body, hey, it's time to wake up and get ready. So it's no wonder that you try to turn off your phone and go to sleep and you're wide awake because your body is releasing certain chemicals saying time to wake up. So due to the continuous day and night operation of most healthcare facilities, it is obviously vital for patients and staff to be exposed to the correct color of light during the proper daylight and nighttime hours. Again, we could be, I hate to say it like this, but you could literally be saving lives by putting and designing lighting to the right spaces within a hospital because you're making the staff that much more effective at doing their job correctly. So big deal. Dynamic lighting. So this is really looking at how we achieve all this stuff. How do we get lights to help us entrain our circadian rhythm or provide more comfort by dim warming or whatever it may be? So tunable white. A lot of us have had experience with tunable white and the effects of tunable white. It's just a function of LED technology, which allows for the changing of color temperature within the same fixture housing. So being able to change Kelvin temperatures with daylight and nighttime color management can improve overall well-being. So again, just the importance of keeping our cycles natural by entraining them with the right light that we're going to be under. Dim to warm. So this dim to warm I would consider almost your most entry basic level tunability. So your dim to warm is similar to tunable white. However, as the light levels are going to dim down, the color temperature becomes warmer. And this technology decreases color temp with lumen output to mimic incandescent lighting. This technology creates a calming environment suitable for waiting rooms and receptions. So this could be seen as easy as one wall slider, 0 to 10. As you dim that fixture down, your lights are going to warm up. So you think about kind of these waiting rooms, maybe it'd be beneficial to have more of this, have control of more of this warmer setting that we can set. We see this all the time kind of in the restaurant industry. So during the day, you have a certain 3,500K, 4,000K And then as the evening comes, they want to set that ambiance. So they're going to dim down their lights, which is also going to warm up their lights. It's the same thing we kind of want to affect in different hospital settings to provide that more comfort feeling. And then tunable color. Tunable color is the end all be all to all tunability. It's going to give you all kinds of application, and it can be applied through all areas of the hospital. You're looking at, reception area, children wings, waiting areas. This LED technology offers full color switching capabilities using various dimming control systems. So tunable color gives you huge range, but it also gets very heavy into controls, as you need certain controls to give you these ranges. The cool thing about tunable color is that we're really starting to see, again, kind of going back to where that green circuit was on the surgical troffer, how certain nanometric numbers, so certain colors, can affect human beings in the space biologically or physically. Or psychologically. So we can implement maybe a certain color that would help calm people. Maybe, and there is studies out there that prove out to be that there's a certain color, blue, that would actually help calm individuals down psychologically when they're under this light. So when they're under this light, we're actually indicating a psychological response to help them, calm their minds or calm their anxiety. So a big win to implement in certain areas where this will be beneficial. So indoor lighting in healthcare facilities is extremely important. It is very important for the outdoor as well, because these facilities are 24/7. So adequate outdoor lighting is critical in a healthcare facility as it is used throughout the nighttime hours. The facility must be well lit for patients to be admitted and vehicles to approach the entrances without the light intruding into patient windows. Cutoff distributions and shielding are used to control such issues. So we really want to make sure that we're designing our outside light to provide the proper amount of foot candles for security, but not also too much where we're intruding into patient rooms, or somebody walks up to the hospital and you got these glare bomb bollards just sitting out there that are really uncomfortable. We want to carry that same element of thought and design that we apply to the inside to the outside space of the hospital. So we kind of start getting into these suggestions or standards on how do we affect this design into the outdoor lighting. So the AMA paper on harmful effects of blue light, its purpose is to illustrate the complications of using blue light in and around medical facilities. As mentioned in the circadian section of this presentation, blue light is harmful in the nighttime hours. Warmer light is recommended for all applications. So as we've come into this LED world, at first we were just basically blasting light on outdoor fixtures. Well, what we came to found is, hey, this isn't the most comfortable light. Not only do we have these glare bombs hanging out here, but we're pumping blue light into people's windows. So we're telling their bodies, hey, it's time to wake up, not go to sleep. So we've seen where some of these studies have come out that say, hey, you need to have your fixtures, stay below a certain level. So one of those would be like the dark sky recommendation. So the IDA, or the International Dark Sky Association, has a recommended practice of color temps not exceeding 3000 K for street and landscape lighting around healthcare facilities for purpose of maintaining good circadian rhythm. So again, really thinking about how your light is going to be used in the space, and then how it's going to be affecting the space even further around it. And we have seen some really cool things. The IES has done some great things lately, kind of on glare metrics with these outdoor lighting. So we do realize that some of these LED outdoor lighting is glaring, it's harsh, and it's uncomfortable. But we have started this process of gathering information to start allowing them to recommend, certain things to help cut down on that glare. So I really think pretty soon we'll start to see the results of these studies and some new standards, kind of recommendations coming out to guide us in this effort. So smart building. So how do we take all that we just talked about, all the odds and ends inside, outside, massive hospital campuses, multi-facility, multi-room. How do we take that all and make it work together in a cohesive unit? How do we do that? So smart lighting, smart building, that's really how we're gonna achieve this. So commercial buildings utilize several different systems to protect those that occupy the healthcare space. Some of these different networks are going to include lighting controls, phone systems, security systems, surveillance systems, fire alarm systems, so on and so forth. Smart building integration takes, what it does is just takes existing Ethernet technologies and new LED technologies and integrates these systems together over the power of Ethernet. So together, not only can you control many of these systems, but you can gain necessary data that will help reduce cost and eliminate energy waste. So we've seen, us approach the hospital realm in these really siloed approaches. And this is the same kind of for the construction industry. Your phones are on one area, your security is on one area, your Wi-Fi is on one area, your HVAC's on one area. Well, now, with smart lighting and utilizing power over Ethernet very effectively, we can tie all this together into one system. And that's really, what the huge benefit of something like PoE enabled smart buildings are going to do. So you have multiple benefits, implementing this kind of technology in the lights that you're using. So safety, customizable resident tracking at senior living facilities. That's huge. And I can personally attest to this when I worked at a nursing home for about 2.5 years in high school. And it seemed like every other month, somebody would walk out the door and just head on out. And it'd be like 20 minutes before somebody realized, hey, this guy's gone. We should go find him. And he'd just, everybody would go out, look for him. We find him. He'd be walking down the road thinking he's going somewhere he's not. But how much more effective could we be for the safety of our residents in these assisted living centers if they have some kind of bracelet on them with some kind of chip and they go under a specific light within the facility that's right next to a door that alerts staff, hey, this guy is right next to an entrance. You could stop them essentially from wandering out before they ever even, get past the parking lot. And then security becomes another benefit to this, a light beacon in emergency situations. So think emergency rooms, crash carts. Somebody comes in just bleeding all over the place. You need a crash cart ASAP. You don't have to look, somebody's hit a button and the lights are cascading to where the nearest crash cart is. So you grab that guy and you're more effective at getting him to the room that he needs to go and get help with. Your health and wellness, tunable white just makes sense with PoE. And you're going to be able to control all this to an absolute degree that's never been done before through utilizing PoE. And then going green, sustainability. We're going to be able to track all of this data, all of this information that our lighting can now provide us. So the question becomes not what my light can do. Putting out light is really the least of my concerns. What else can my light fixture do? What kind of sensor can I attach to it? And so I can see throughout a hospital, instead of investing in maybe a new building, it's like, well, I have all these rooms that aren't being used through certain times of day. So maybe I can just rearrange things and utilize a certain area of the building that is not being effectively used and save myself millions of dollars from building another facility right next door. So a lot of benefits, a lot of things to think through and just kind of consider in your conversations as you're designing these spaces. Hey, what's one option? PoE is definitely one. I think for hospitals makes a massive amount of sense. So just kind of keep this on your radar as you're designing these spaces or looking at these spaces. So this is kind of gives you an example just of what a PoE lighting system is. So PoE solutions for smart building, control all the stuff we just talked about. Its user interface easily creates action sets, scheduling and policies. Gateway, host computer for lighting system. PoE switches route data between the lighting system software and fixtures. Buttons and sensors. Accessory nodes provide connectivity for wall buttons, room sensors, and non-PoE lighting. So PoE lighting does not have to be complicated. It's actually relatively simple. And it just really levels up your fixtures to a level that I don't think in the lighting world has really been seen yet, but I really think we're seeing some of this technology like PoE take off just because it allows the end user so many more options, so much more control, and you basically future-proof your lights by enabling this kind of system. So this concludes the American Institute of Architects Continuing Education System course.